next bias we're going to talk about is the availability bias. And with the availability bias, our decision rule is if it's something that's easily accessible to me or readily available for me, I am far more likely to put emphasis on that information, even if it's a rarity or it's irrational. For example, we have a greater fear of shark bites than we do of slipping and falling in our bathtub, when we're far more likely to die from slipping and falling in our bathtub than we are from a shark bite. Just in the example that I have here on in the slide, we're more likely to die from a car accident than an airplane crash, but because an airplane crash is so much more impactful because the statistics are so huge, right? 200 people die, 500 people die, whoever's on the airplane. That has more salience to me rather than the probability of how often an airplane crash is going to happen. And so we know that it's actually safer to fly in an airplane than it is to drive in your car. You're much more likely to be in a car accident than you are to be in an airplane crash. Now, also, we have to take into account that if an airplane crashes, the probability of anybody surviving is fairly slim. But also, regardless of that, the probability of an airplane crash happening relative to a car crash are slim to none, and dying in a car crash rather than as opposed to dying in an airplane crash. So we irrationally seek the most available information to us without really going in deeper and looking at probabilities and looking at things in a more balanced way. So, because we assume our experiences are balanced, but they're actually not. And here's the thing also with respect to man and man's ability to think through things and to reason through things as compared to models. Models of man and models of our decision making outperform man every single time, because if we set a decision model with a certain characteristics and we add in the data and then we have the decision model make a decision for us versus us looking at the data and making the decision on our own, we are biased, and the models of man and the algorithms outperform man every single time. But we don't trust the algorithms, even though the algorithms outperform us, because we somehow believe that we will have more information than the algorithm has. That doesn't mean this is true in all circumstances, but the probability of the algorithm outperforming the human is far more likely than it is for the human to outperform the algorithm. So we are simply the product of our experiences, and we assume that those experiences are balanced. We assume that they're relative and they're rational, and we assume that the probability of them happening are equal. Like, there is no equal probability of a car crash and an airplane crash. Yes, if an airplane goes down, the damage is huge, but the probability of it happening is very small relative to the probability of car crashes happening. If you were to do the research on the statistics, you'll see absolutely that cars are more dangerous. So we do distort risks and probabilities because we only use sort of that knee-jerk reaction data that's available to us, and we don't really dive into it and look into it in a deeper and more probabilistic way. Then we have representation bias. And representation bias is assessing the likelihood of an event based on how closely it resembles some other event or set of events. And we saw a lot of representation bias going on during the pandemic. For example, people saying, well, all of my friends were vaccinated and they got sick with COVID, so the vaccine doesn't work. When in fact, if you were actually to research it deeply, people who got vaccinated were it didn't mean that they weren't going to get sick. The probability of them getting sick would be less. And also, if they got sick, their symptoms would be less than if they didn't get vaccinated. This is what the research shows. And so the representation bias becomes the problem in that we only work with the data that's around us, kind of similar to the availability bias, but it's the same thing. It's a similar thing, um, in that we think the likelihood of something happening is generalizable to the public because the small sample that we have in front of us is a certain set of things. And so you might have a lot of friends who were not vaccinated, who were vaccinated, for example, and you were far more likely to see them getting sick. Even if it was mild, they still got sick. And again, this presumes it's an all or nothing switch, that everybody either got sick or they didn't get sick, when you forget that there's a whole continuum of what would happen between not getting sick at all and being so sick that you died from it, that there's a whole gradation of sickness between those two extremes. And what you saw is vaccinated people were far more likely to be on the lower end of being sick, and unvaccinated people were more likely on the higher end of things. But often we spend our time talking about the small sample that we have in front of us. Well, in my experience, these three people that had it were sick, so therefore everybody, that's what's going to occur for everybody. And that's what we mean by representation bias. Your sample that you're using is a very biased sample, and it's usually based on the people we have in our life, the people that have shared values and interests with us. And so we are far more likely to see certain things in a certain way based on that biased sample that we're using. The other thing with representation bias is it ignores randomness. It assumes when we see a small sample of things that there's a pattern or a trend when there is none. And this is where dopamine comes into play. If you remember that little podcast from Jonah Lehrer in the first module, where they talk about dopamine and dopamine's desire to find patterns or trends in things. And that's what dopamine's goal is. And it gives us pleasure because we see the pattern, and the pattern gives us pleasure because there's a reward at the end of that pattern. So it assumes that we're on a lucky streak or that there is some sort of pattern there when there is none. So representation bias is a biased sample, and it does not give us a good representation of what is really all the possibilities of what could occur. You also have to recognize too that when we see outliers, it doesn't mean that those outliers are really representative of a trend or representative of what's going on. So what we might see is a trend of data. And let's say we see in a short period of time, last year, 2 years ago, last year and this year, the data seems to be going down. So maybe it was at 100, then it was at 50, and then it was at 25. But what we don't realize is those years before were all really low. And so they might have been low, 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 low. And then it was one weird year where it was high, but then the other years go back to whatever the average was, which was 25, 25, 25, 25. So high performers one year are far more likely to decrease towards the average, so we call it regressing to the mean. So outliers, they're just outliers. And sometimes a rare circumstance happens, something unusual will happen. You have to look at longer term data, not just short snippets, but longer term data to truly get a sense of what's going on longitudinally with something. 2 or 3 years is not a good representation. You need to go back at least 10 or 15 years to look at really good trends, to know what the trends are, whether or not you're averaging at 25 or are you averaging at 100. And we need to look at that way. And it's the same thing for low performance. Like if you have an incredibly low performance one year, the next year they're very likely to go up to whatever the average performance was. So you might have 25, 25, 25, and someone was at 0, and then we see 25, and then we might think, oh my gosh, look, we got a 0 and we've got a 25, and oh, it must be increasing. And in fact, it's not. It's just going back to whatever the average was in the first place. We also want to think about sample size concerns because we want to make sure we've got representative samples. And representative samples have to be a certain percentage of what we call it statistical power. We need to have statistical power. So we need to have a certain sample size that we believe is a reasonable subset of what the population would do in order for us to be able to understand and interpret and generalize based on those statistics. So subsamples of things are typically not always representative. There's a big difference between looking at a number that says 3 out of 5 people believe this versus 1,200 out of 2,000 believe this. There's a lot more power behind 1,200 out of 2,000 because the numbers are big versus 3 out of 5. Now, mind you, 3 out of 5 is what the proportion is between 1,200 and 2,000, right? You can do the math. You can look at that, right? Because 3 times 400 is 12, 5 times 400 is 2,000. So you can see how that's comparable. But if someone says to me 3 out of 5, if I'm assuming they've only collected 5 samples, that's a really big difference than saying they collected 2,000 samples. 2,000 samples gives me a lot more information, and I'm less likely to assume that the information is erroneous or not going to be accurate. So 3 out of 5 versus 1,200 out of 2,000, yes, they're the exact same thing, but we want to be careful of not relying on small samples, whether it's small samples of the people and friends around us, or it's the small sample of the employees that I interact with, or the organizations that I've worked for. These are biased samples, right? And we have a biased opinion about them, either to the positive or to the negative when it comes to those things. We've already spoken a few times about coping with randomness and this notion that we're trying to predict that something is going to occur based on a random event. For example, if you go into a casino, casinos are random generation, the one-armed bandits, the slot machines are random generation events. So someone's pulling that one-armed bandit. There isn't a system. There's not a gimmick that you can do to generate more wins coming out of a slot machine because they're random generated. And dopamine wants us to be able to predict a pattern. It doesn't like random things. It doesn't know what to do with random things. So it seeks to try to make an association between things that aren't likely going to happen. But nonetheless, we want to be able to predict these things. So human beings struggle with chance happening. We don't like the idea that we don't have control over our lives. So let's go back to our lecture on individual differences where we were talking about control. If I have a high internal locus of control, I really struggle with random things because I don't like having things that I can't control. Alternatively, if I am having a external locus control, I am more comfortable with things that are random because I can adapt and I recognize that random things are going to happen whether or not I like them, and that I have to simply adapt to them as they occur. But someone with a high internal locus of control struggles with that. So we have to recognize that randomness happens and that there are times when we can control things and there are times we cannot control things in the way that they come at us. We ascribe far too much meaning to random events when really, in fact, there's no meaning to them at all. It's not fate. It's not kismet. It's not, it's not predictable. It's not a pattern. It simply is the bottom line. Things are random and they're going to happen, and we have to let go of our ability to actually predict those things. We just have to remember coincidences happen. There's always going to be coincidences. There's always going to be things that occur that seem like they might be related to each other. They seem like they might be correlated when in fact they're not. Our next bias is sunk cost, or you also may hear it called escalation of commitment. It's the same bias, but it's just two perspectives on the way you think about it. If we've sunk too much money into something, we have escalated our commitment to it. So if you think about it that way. And so basically what a sunk cost means is that it's treating a non-refundable past expenditure as the equivalent of something that we are going to invest in the present moment. So it means that we equally value and equally weight past expenditures and current investments as if they mean the same thing. But what we have to recognize is we have to make a decision in the moment based on whether or not something has value in the moment, not looking backwards and saying, well, I've already invested $25,000. What's another $25,000 to put into it? So a sunk cost means we can't consider past information. We can only consider at the moment, is there value in adding more money into a project because the money will have value, versus a commitment to say, well, I've already invested 100,000, what's another 20? That's an escalation of commitment. And there's a point where we're fine doing this, right? It's like, I put 25 in, maybe another 5, let's see what that comes out to be. But once we start seeing ourselves going, but it's just another 5 and another 10 and another 20 and another 5 and another 10, we start seeing it escalating, and we are committed to something and we're not willing to back off of it. Why does that happen? Because it looks like we are indecisive, or that we made a mistake, or perhaps we're wasting resources, or we quote unquote want to save face, such that I've already made some bad decisions, so I'm going to put good money after it, so it looks like this is still a good decision to make. And obviously that's not going to work. That doesn't work for people, because what we did in the past has no relevance on the decision that we need to make now and in this moment. So don't worry about your ego. Don't worry about looking bad or wasteful. Sometimes we have to look at a project and say, we're done. We've done everything we can. It's time to move forward and move on. And we cannot sit back and assume that old investments matter the same as current investments. Because once the money's gone, it's usually a different fiscal year or a different budget line. We don't want to keep referring to that as if it's the same money that we're investing today.